All right, in our last video, we talked about nested for loops. We talked about breaks and continues, and what we said we need to do is talk about breaks, continues, and passes. I guess we got to cover passes as well in while loops, and we'll do that. But first, the math nerd in me just can't help but show you that this code is super slow. We kind of saw it before, but if we generate the primes less than a million using this process, let's see how long it will take while I explain to you how we can make it faster. So here's how we're going to make it faster. We're going to, all right, and let's make this markdown. We're going to show you how we can speed this up. And if you did some Googling to generate that code up above, maybe it wasn't my code, but that's fine. But if you found an answer that was generating primes up to 100, then great, you solved the task. And honestly, that's sometimes part of your job as a programmer is just to know how to Google something and get code that will work. And the hard part of that is verifying it does work, right? That's a big step. And the other part is knowing if the code you got was well written or not. Now, well written could be in terms of how readable it is, and I do think this is I'm kind of saying I think this is fairly readable code. I think it makes somewhat sense. We haven't put comments in it or anything to make it super readable, but I think anyone who is interested in prime numbers would be able to see this and read it, especially with the very wordy variable names, and understand what's going on here. Now, the issue is that there are smart math people out there who know that this is a super slow way to generate prime numbers, and we're going to figure out one extra line we can put in this and solve it a lot faster. And we're going to explain that one line to you now. So let's talk about not prime numbers. So some composite numbers like 25. 25, right, is not prime. And I want you to think about what number divides 25. It's divisible by 5 and itself. 25 is 5 times 5. Now, in other words, what I want you to notice here is, hey, 25 is, I would say, maybe fairly big, and 5 is fairly small, and so it only took a fairly small number to figure out that 25 was not prime. Let's look at a bigger number like 121. Same idea, 121 is not a prime number, and maybe even more surprisingly, the number that divides it cleanly is 11, but also the complement or the other factor in that scenario is 11. It's 11 times 11, so two 11s are making 121. And once again, those are pretty small numbers that are making a fairly big number like 121. So then what is the issue with our code? Well, what I'm trying to show you here is that mathematically, you don't need to check any primes that are, bigger than the square root of your number. And that's why I chose 25 and 121. Now, what's the problem with our code right now? Well, let's think about the prime 29. It is prime, and let's see why our code is going very slow. Because what I'm telling you right now is, while 29 doesn't square root nicely, right, here's what I know. 25 square roots to 5. I know that 36 square roots to 6. And so I know that since 29 is less than 36, the only primes that could work are the primes up to 5. So that's what you might have Googled, and maybe you could watch a second video on it, and maybe that's what my second YouTube channel will be. But in other words, we only need to check the primes up to 5, and if you look at the way our code is structured right now, right, for 29, here's the primes we've found already. We found 2, 3, I'll just write them next to each other, 5, 7, 11, 13, 17, 19, and 23. And what I'm telling you is we don't even need to check past 5 based on this logic up here. And think about that. 29 is fairly small, and there are, 8 primes in this list, and we only need to check 3 of them. Now think about how crazy that would get up here when there's maybe, thousands of primes, but we only need to check 10 of them. Then we're wasting 990 steps that are unnecessary. And trust me, it's probably worse than that. as we get larger and larger, and it's still not done after 4 minutes. So let's add in that one line and be done with it. Here's the one line you need to add in. You could say L if the prime that I'm checking against my number squared is greater than the number I'm investigating, then I should just go ahead and break. Now, in other words, I'm saying, okay, for 29, right? What's going on here in this example? For 29, it's going to say, does 2 divide 29? No, it doesn't, so I'm not going to break. Is 2 squared bigger than 29? No, it's not, so I'm not going to break. What about 3? Well, it doesn't divide it, but 3 squared is not bigger than 29, so I'm also not going to break. Finally, 5, well, not finally, but 5, does it divide 29? No, it doesn't. What's 5 squared? 25, but that's not bigger than the number, so I'm not going to break. Finally, what's 7, the next prime? Well, 7 doesn't divide 29, but 7 squared is 49, so I've now jumped way over my number, and because I've jumped way over my number, I'll stop at 7, so I don't need to worry about checking 11, 13, 17, 19, or 23. So I only had to check those 4. And this code still didn't finish running, so let's stop it now. So it still couldn't get the job done. Now let's try it again. And this is just amazing every time I see it. It's done in less than 5 seconds. Now, this, again, is the big point I was trying to make, that as you're writing code and you're learning to program, it's honestly less about the language you're using and understanding the problem you're trying to solve. Programming's hard for 2 reasons, because you are learning a new language and you are probably learning how to problem solve certain questions that you never knew you were being asked. And so that's a hard task to do at times, to juggle both and to learn both simultaneously. But you can do it. It can be done. And that's kind of what we're here to do. So this is some early exposure into that, just to show you, wow, one line of code can save you from running for longer than 5 minutes and still not having an answer, to running in under 5 seconds and having the answer. And we can confirm that. If you Google how many primes are less than 1 million, you'll find it's the same as how many primes we've now stored in our list. So that's pretty darn amazing that we were able to do that in less than 5 seconds. All by just knowing one extra line of code. So knowing the problem you're trying to solve, super important idea. And you need to spend time researching and thinking about how you can structure your code to run, maybe even before you write a line of code, and that will save you so much time in the long run, right? Because I can have this code run for 5 minutes, but think about this. What if I run this code for, I don't know how long it will take. What if I ran this code for 10 minutes and then I still found a bug in the code? I messed up my if-else logic somehow and I didn't actually get the right output. Then not only did you sit there for 10 minutes just to get the wrong output, but you didn't spend time debugging in the meantime. So it's saving you time as you're preparing to write your code. It's saving your time as your code is running, and it's saving you time maybe after your code runs, because you're still being able to go back, double check, do other tasks in the meantime. So it's doing twice the work up front will save you probably hundreds of times the work in the back. So just know that, again, there's the literal example. Doing 1 or 2 extra minutes of research, knowing that I didn't need to go past the square root of the number I was looking for, or squaring the prime to know that it's bigger so I can stop, saved me probably over 100 times the amount of wait time. And I'm now able to move on to bigger and better things. So, okay, let's now look at while loops, and let's do something a little bit less mathy and kind of domain specific to math, and just talk about games and playing games, because we're going to build up and build a game at some point here, and that'll be pretty exciting. So when you're playing a game, the idea is, the game has to be over at some point, but let's say the game isn't finished yet. So is the game finished? No. Well, what happens when the game isn't finished? So while not game finished, well, what does it mean if the game's not finished? Then it means we're probably taking turns back and forth and back and forth. So maybe I've got 2 players playing a game. I've probably come up with those players beforehand. And maybe I'll store them in a list. I've got Bob and I've got Alice. All right, so while the game is not finished, what I can do is I can say I want to print the turn of the current player. It is, now let's see here. How am I going to figure out what turn or whose turn it is on what turn? Well, let's see here. I could probably say that the current player is set at index 0. And then I could say it's player's player turn. Now that looks really wacky. And sorry, let's even do this outside of the while loop. And I've actually done this for a little bit of a reason. So what we're going to do is we're going to figure out how to use the pass statement. Well, we can't really do it with a while loop, but let me just go ahead and tell you what pass will do. Pass is essentially just a filler for I will write stuff in here later. Now, honestly, you probably don't see pass a lot in like full production code. You should probably see something like continue or break, but usually we write pass as a placeholder. Now, the reason I'm not going to do that, or I guess I'll do it, is notice that this is still running forever because this while loop is actually just reading pass over and over and over and over and over and over and over again because there's no other logic to get the game finished. So pass, again, there's not a bunch of big ugly stuff happening in the while loop, but notice my code is still running. But notice it didn't break because if I don't have anything in there and I start going back up, I'm going to get some error saying, hey, you didn't put anything in here, so I have no idea what you want to do now. All right, so, okay. What did work, sorry, just to put it back there, maybe I'll even just put break immediately, and then it will just stop immediately. So the game broke, but no one actually did finish, but that's okay. But I want to just show you that this F string is working. So it's saying it's players, and players is again the list, and it's players at the 0 index turn. So who's at the 0 index? Bob. So right now it's Bob's turn. If I write player 1, then now it says it's Alice's turn. So great, we have a way to reference the player's name. So that's pretty cool. So we'll start off with player 0. Bob will go first. And we'll also want to know what turn it is. Let's say it's the first turn. Well, all right, then what we can do is we can put this line of code in there. And we'll have to indent it to be inside the while loop. So we can say also print, and we'll say turn. So now let's break out of that just for the moment. So it's turn 1, it's Bob's turn, and we stop. Okay, now I stopped because I didn't want to see this running forever, but what goes on in a game is, I don't know, maybe they're playing some sort of card game. And again, we are going to build out a full game, but right now it's more about like the idea of structuring games in Python is kind of what we're doing here, just understanding how we could do it. So maybe what I can say is it's turn 1, it's Bob's turn. And we'll print something else. We'll say, actually, we won't print. We're going to get some input from Bob. And there's a way to do that. We want to know Bob's turn move. We'll store that in a variable. And we'll say that Bob's turn move comes from the input. And we'll say, what would, and we'll insert player's player. We'll insert Bob's name again. Back into this. Whoops. What would player's player like to do? And we'll say, I don't know, maybe they can draw a card, maybe they can play a card, maybe they can do some sort of trap, I don't know, or maybe they can just outright win. Maybe they have enough cards to win or something like that. All right, so now let's see what happens. Notice now I'm not going to need to write break or anything. We're going to see something new in Visual Studio Code, and depending on your editor, you're going to see how input's handled in a different way. But let's see what happens now. So it says it's turn 1, it's Bob's turn. What would Bob like to do? So see, we still get the formatted string there. And what I can do now is I can say draw a card. When I run that, okay, it took that information, but it's still turn 1 and it's still Bob's turn, and I didn't do anything with that input. But I guess I just want to show you. Whoops, I gotta press escape to get out of this, or I'm just gonna quit this. There we go. and then escape. You can get stuck in a while loop for quite some time, so sometimes you just have to press restart or clear all output, but that's fine. But now what do I want to do? So, okay, we have a turn move, and in fact, we can even print the turn move. All right, and we could make that a nice little F string and say like Bob chose to blah, 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 but we'll just move on from there and just know that we can print the turn move. But what we need to do now in our game is we need to change the player and change the turn it is. So how can we do that? Well, in a while loop, of course, we could always then just say the turn plus equals 1, because there's always going to be another turn. But now let's do player plus equals 1, and maybe that'll be enough. And I'll go ahead and tell you it won't, and let's see why. Okay, so, whoops, where are my other print statements? Let me restart. Clear outputs. There we go. All right, so turn 1, it's Bob's turn. What would Bob like to do? Let's say Bob wants to draw a card. Great, so draw a card. Turn 2, it's Alice's turn. What would Alice like to do? Let's say Alice wants to play a card. And it says play card turn 3, and now we get an error and we broke out of our game. Now, hopefully you know what the error is. It says index out of range. But hopefully you know why it's indexed out of range, and it's because when we just simply increment the player amount, now it's saying, okay, it was 0, it went up to 1 for Alice's turn, but now it's going to go up to 2, but there is not a second index. There's only a 0 index and a first index, so that's the index out of range. We're now looking for like the player at index 2 or the third player, and there isn't one. So we're going to need to be a little more creative with this player plus equals 1. And there's two ways you could do this. You could say if, let's see here, player equals the length of players. And sorry, we will do player plus equals 1 actually still. So we're still going to add 1. But now when I get up to 2, there are 2 players. But when player increments up to 2, we can just force it back to be 0. All right, so let's just demonstrate this and show what happens. So it's Bob's turn. What would Bob like to do? We'll say draw a card. It's turn 2. It's Alice's turn. Let's say she wants to play card. Now it's turn 3, and it's back to Bob's turn. And let's say Bob wants to trap. I mean, these don't do anything. We could say that it's Alice's turn. What does Alice want to do? And we could say fetch, and that's not even a real thing. So we're not doing any logic with this. We're just printing it out. So we could put nonsense in there. But notice that we've solved our turn problem and our player problem by putting this logic in. Now, I think that logic is a little bit messy. I think there's better ways to handle it. And here's how I would handle it. I would say, let's see here. I want player mod length players. So actually, what would I do here? I would say I want players to equal player plus 1 mod length players. Now this is kind of a clever way of writing it, but essentially what's going on here is it's saying I want you to take the current player amount, add 1 to it. So using that plus equals, essentially just writing it out a little bit, I guess more naturally. And then I want to mod that by the length of the players. Now, if you write it like this, here's the good news is the way we wrote it before. Let's see if I can undo. The way I wrote it before only works. Actually, no, it does work in all scenarios. So it works if it's 2-player game, 3-player game, because I wrote like length players. So really, the bad thing would be is if you wrote like if player equals 2. Because what if you're playing a 5-player game? Well, now you're never going to get to players like 3 and 4 based on their index. It's going to break out early. So you need to reference somehow the length of players and not just hard code 2 in there. That's a concept we call putting magic numbers in. And it's where you're not allowing your game or your program to be dynamic, or you're not explaining the context of the numbers. If you know your game is always a 2-player game, then maybe just putting 2 here works. But if your game, the amount of players can change, then you might want to make your code a little bit more flexible and put length players in there. I like, again, the reason I like doing it is because it's just fewer lines. But I like saying player equals player plus 1 mod length players. Just me personally. Now, you do need to nest that in parentheses so that it does the addition first and then the division because of PEMDAS rules. But that's another way to do it. Okay, let's see what else we can do. We need to do some continues and other things like that. So let's say we want to do something like figure out what trap means. And maybe, for instance, trap means that you get to take another turn somehow in whatever this game we're playing is. So what we can do is after the turn move is made and they type in trap or something, what we can do is we can say if the turn move is equal to trap. Whoops. That was a very interesting autocomplete. So if the turn move was trap, we could maybe say print players player decided to, and then we'll see what their turn move was. They will take another turn. Whoops. Oh, there it is. I forgot to close that out. Whew, that looked crazy for a second. Okay, so they will take another turn. Great, now we know they take another turn. I'll put in that new line just to see it nicely. And so then what's going on there is, okay, when they take their turn, here's what can't happen now. I do need to increment the amount of turns, and I'll need to do that in this if statement, but I now don't want this to happen. Now what I could do, right, is I could say turn plus equals 1, and I then could have another if statement that says if turn moves equal to trap player plus 1 or whatever. I think what would be kind of cooler to do is just to say, hey, continue. So I'm still going to increment the turn and I'm going to continue, but I'm not going to double increment the turn and I'm not going to change the player amount. So let's see how this works now. It's Bob's turn. What does Bob want to do? Maybe Bob wants to draw a card. Whoops. Where's the rest of my prints? Give me a second here. And let me restart. So sometimes, yeah, Visual Studio Code will be a little bit interesting with that input and prints, but there we go. Okay, so it's Bob's turn. Let's say draw a card. All right, now it's Alice's turn. Maybe Alice wants to play a card. And maybe it's Bob's turn and Bob decides to trap. And then it says Bob decided to trap. They'll take another turn. And notice it says it's turn 4, but it's still Bob's turn. Okay, well, now Bob play a card. And now it says it's Alice's turn. I'm getting, again, that kind of print error stuff happening. If I quit out of this, I don't know why it does that, but if I quit out of this, you'll see it then said Alice's turn. But you get the idea that we've now built in a way to just use a simple continue rather than needing to put another if else down here afterwards. And the continue allows me to increment my turn and then not worry about modifying the player or count the turn in double count accidentally. So another use of continue there. And whoops, let me quit out of this. Of course, now this isn't how you really win a game. You don't just say I want to win, but what we could do is we could say elif the turn move is equal to win. Well, then of course we want to print the current player 1. And at that point, you're done playing the game. Now, there's two ways you could just end the game. You could just press type break, and then the game's over for sure, right? That would be one way of doing it. So let's just say it's Bob's turn. It's first turn, and they want to win, and they type win. Hey, great, Bob wins, and we quit the game. Now, another way we could do that is, of course, instead of using break, we could say game finished equals true now. Now that would have the same effect because if I then decide to win, then once game finished is now true and we go up and read this statement, while the game is not true, well now not true is a false statement, so we quit out. But break would do the same thing there, so there you go. You could think of maybe lots of scenarios where you might want to continue in a game and like let a player have another turn, or you might want to break. Maybe there's a sub process they do in their turn where there's some other thing that they have to do that you have to break out of afterwards. So there's lots of different ways you could use continue and break. And finally, what you could also do is, let's say elif the turn move is draw a card. Now, we don't need to put anything in there, but if the turn move is equal to draw card, we could just write pass. And again, that's a way of just in our programming. Let me quit out of this while it's thinking. Then let me restart. What pass will do is pass is, again, kind of a programmer's way of saying, I haven't built in the logic here and I know I've got something I want. I just haven't put it in there yet. Or maybe it's a way of saying, I actually don't want really anything to happen with this condition, but I still want to note it somehow in my code. And with that, we've covered continue, break, and pass for while loops, and we also nerded out and talked about prime numbers a little more. So thank you for joining me on these 2 videos. Finally, in the next video, we are going to talk about functions, and from there, we'll start really dealing with functions and some more nerdy stuff like this, and really building out things like games, because functions are a big part of that. So I'll see you then. Thank you for watching.